So let's talk about quadratic form. So you've probably factored quadratic equations before, right? So quadratic form is something that looks like ax squared plus bx plus c, right? So, right, where a, b, and c are the coefficients. So in other words, right, this variable is the middle variable squared. So we're going to see how that extends to something called quadratic form, which is taking higher powered polynomials, so higher than x squared, and rewriting them so they look like quadratics so you can use your basic factoring techniques. So the first problem we're going to look at as an example today is we're going to solve, right, all of these are going to be solving, of course, right, x to the fourth minus 11x squared plus 30 is equal to 0. Okay, right, so right off the bat, this is x to the fourth, which is bigger than x squared, so it's not a quadratic equation, right? We have a nice quartic equation. So this fits quadratic form because we can rewrite this problem right, so we have our middle term is x squared, and x squared squared is x to the fourth. So we can actually make this look more like a quadratic equation. And I'm going to show you two ways to do this because some people are really comfortable with just rewriting it and then solving it like this, and other people this makes them really uncomfortable. So I'm going to just show you both methods kind of simultaneously. So over here I'm going to say, let's let w equal x squared. So then what this problem becomes is x squared squared becomes w squared minus 11w plus 30 is equal to 0, right? So that might be a little bit more comfortable for you to do. So what this method is called is just substitution. So I'm just going to show you both ways of solving it. So one way is to not do substitution and just leave all the variables as is and factor it like normal. And then the other one is to do a substitution so that way it totally looks like a quadratic equation and just factor, and then you have to re-substitute in at the end to put the variables back to what they were. So if we have a quadratic, right, we have a trinomial, right, we want to remember that you want to multiply to the c value in this case. So we want to multiply to 30 and add to negative 11. So that's going to give me negative 5 and negative 6. So when I go ahead and factor this, right, my negative 5 and my negative 6 are the two numbers that go in the end. And then all you do is you take this middle variable, and that's what goes in the front spot. So I get x squared minus 5 times x squared plus 6. And then we're going to set them both equal to 0 and solve for x. Right, so I'm going to show you how it's the same way in the substitution. Right, so the diamond puzzle, that little math thing, right, 30 and negative 11, those numbers are the same. So this over here still factors to w minus 5 and w minus 6. Right, so then I would set both of those equal to 0. But then w is equal to x squared. So now wherever I see a w, whoops, that's not what I wanted to do. I'm just going to put x squared back in. Right, so then we can see that we get exactly the same equation. So it doesn't matter how you go ahead factoring it, just some students are really uncomfortable factoring with like the x squared in parentheses like on the left, and they just want a normal squared like quadratic equation looking thing. So that's when substitution is super handy, but you don't have to do it. So I'm just going to solve one of these since they're exactly the same equations, right? So here I would add 5. To get rid of a square power, you got to take a square root. Now remember, when you take the square root of a variable like this in an equation, you get a plus or minus, so x is plus or minus the square root of 5. and then here I'm going to add 6. So x squared equals 6. Do the same thing, take the square root. Just going to give me a plus or minus on my answer. And 6 is not a perfect square, just like 5, so we're going to leave it like that. And then we have, since we have plus or minuses on our 2 answers, that means we have a total of 4 answers, which fits since we have a quartic degree. So we're going to look at a total of 2 more problems. So let's look at something like this. Let's solve x to the 4th plus 2x squared minus 48 is equal to 0. So for the last 2 problems, I'm just going to leave all the variables as is. I'm not going to do substitution. So for this problem, right, whenever you have 3 terms like this, you always want to check to see if you can make it look like a quadratic equation. So I look at my middle term, and I see x squared, and then I know that x squared all squared is really just x to the 4th. So I'm just gonna color code it a little bit. Right, so then I have a normal looking, well, it's a weird looking trinomial because of the x squared squared, but we have a typical trinomial quadratic factoring pattern. So I need to multiply to negative 48 and add the 2. So that's going to be positive 8 and negative 6. So I'm going to go ahead and factor. And since my a value is 1 here, there's like no number in the front of the problem, I can just go ahead and jump to my answers. And then I'm just going to take my middle variable and put that in there. So I'm going to go through and solve both of them. So here I'm going to add 6. Here I'm going to subtract 8. We'll just do these simultaneously. I need to take a square root. Right, so that's going to give me plus or minuses on my answers. So x is going to equal plus or minus. Since I have the square root of a negative, I'm going to just pull the I out. So I get plus or minus I square root of 8, and then x over here is going to equal plus or minus the square root of 6. And now, right, the square root of 8, I can rewrite that as the square root of 4 times the square root of 2. And the square root of 4 is 2. So my final, like, fully simplified answer for this one can be plus or minus 2i square root of 2 by simplifying the square root of 8. And then I can't simplify the square root of 6 at all, so I'm just going to get my final 2 answers from here. So let's look at one more problem, and let's just bump the factoring up a little bit. So let's look at something like, let's do this one. So for our final example, we're going to do 3x to the 4th minus 19x squared plus 20 is equal to 0. So the first thing I'm going to do is notice that I can make this into quadratic form. Right? So if my middle variable is x squared squared is x to the 4th, so this fits the pattern. And then I'm going to go ahead and factor. So now I do have an a value here, so 3 times 20 is going to give me, I need to multiply up to 60, but add to my middle value of negative 19. So since I'm multiplying to a positive, but adding to a negative, that means both my numbers are negative. And then the 2 values for me that are going to do that are negative 4 and negative 15. So I'm also going to actually employ split the middle technique, which means that we're going to actually end up factoring by grouping. So what I'm going to do here is I'm going to rewrite my negative 19 as, I'll do negative 15x squared minus 4x squared. And then I'm just going to bring down the rest of this stuff. And so now I'm actually going to rewrite the x to the 4th as x to the 4th instead of x squared squared. And that's just because it's going to make my factoring by grouping a lot easier. So now that I have 4 terms, I can cut it in half and take out my GCFs. right? So these are both divisible by 3, and they both have at least 2 x's. So I'm going to take out 3x squared, and I'll be left with x squared minus 5. And then over here, the 4 is negative, so I need to take out a negative, and then both of these numbers are divisible by 4. Right, and then I'm going to get x squared minus 5 back. So I'm going to take my common group, write it in the front, by factoring it out, and then take my second group as my leftover GCFs. So I'm going to set both of my groups equal to 0, and then finish solving for x. Right, and if I check back to the original problem, we had an x to the 4th to start, so I should be getting 4 different answers, right? I was saying the word 4th while I was writing and wrote a 4 instead of a 5. Whoops. Right, so here I'm going to add 5. And then to get rid of my square, take a square root, which is going to throw a plus or minus on my answer. So x equals plus or minus the square root of 5. So there's half my answers, right? 2 of my 4. And then here I'll add 4. And then I'm going to divide by 3. So x squared equals 4/3. I'm going to take the square root of both sides, which means I'm going to take the square root of the top and bottom of my fraction. So I'm going to throw plus or minus on the front. The square root of 4 is 2, and then the square root of 3 is just the square root of 3. And then depending on how you have to leave your answers on whatever your directions are, you could leave it like this because this is an answer, or if you need to rationalize it, right, we want to cancel the square root of 3 in the denominator, so I'm going to multiply the top and bottom by the square root of 3. So that would give me plus or minus 2 square root of 3, and then just doing this off to the side here, right, the square root of 3 times the square root of 3 is the square root of 9, and the square root of 9 is just 3. So there's our fully simplified